Now remember we saw sine 2x, cos 2x, right, and tan 2x. So let's look at 3x. So let's see 3x, 3 sine x minus 4 sine cube x. What I would suggest is, learn how to derive it so that you don't have to remember it. Okay, so sine 3x can be written as sine 2x plus x. We know sine x plus y is sine x cos y plus cos 2x sine y. Okay, so here y is x. Now here a little bit tricky part. We have ended up with sine 2x cos x plus cos 2x sine x, right? We know the identity for this. So sine 2x is nothing but 2 sine x cos x, and there is already a cos x here, plus now cos 2x is what? Now there might be multiple identities related to this itself, cos 2x itself, but remember we require sine cube x. So sine cube x we already have a sine x, so that means we require a sine square x. So keeping that in mind, choose the appropriate identity. Now 2 sine x, now this is cos square x plus distributive property sine x minus 2 sine cube x. Now this should also, see, in our identity there is no cos, so this should also get converted to sine. So 2 sine x 1 minus sine square x. Again distributive properties, 2 sine x minus 2 sine cube x plus sine x minus 2 sine cube x, which means, now remember, this and this are like terms, this and this are like terms. So 2 sine x plus sine x is 3 sine x minus 2 sine cube x minus 2 sine cube x is minus 4 sine cube x, which is what we needed. See, as you keep practicing, right, you will be able to do many of these steps in your mind itself. I am writing many more steps for clarity purpose. Okay, 24. Now we have seen sine 3x. Let's see cos 3x. 4 cos cube x minus 3 cos x. Okay, remember cos 3x can be written as cos 2x plus x. See, once you know the trick, it becomes easier. Now we know cos x plus y is what? Cos x cos y minus sin x sin y. So cos 2x cos x minus sin 2x sin y. Now in our identity there is no sign, so this sign has to be converted. So cos 2x, okay, cos 2x is an identity and we want it in terms of cos itself. So 2 cos square x minus 1 to cos x. Now the sine have to get converted to cos. So first let's take care of the identity of sine 2x. It's 2 sine x cos x. Sine x. Okay. Distributive property. So 2 cos cube x minus cos x minus sine x sine x. So 2 cos x sine square x. Now this sine square x has to be converted into cos. One minus cos square x. Two cos x minus into minus plus 2 cos cube x. 2 cos cube x. 2 cos cube x is 4 cos cube x. Minus cos x minus 2 cos x is minus 3 cos x, which is what we needed. 25th. Let's do tan 3x. Okay, is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. Okay, tan 3x can be written as tan 2x plus x. We know the identity for this. Tan 2x plus tan x divided by 1 minus tan 2x tan x. Now we know the identity for tan 2x. So 2 tan x by 1 minus tan square x plus tan x. This whole thing divided by 1 minus, again we know tan 2x is 2 tan x divided by 1 minus tan square x into tan x. Okay, let's take the LCM now. 2 tan x plus tan x times 1 minus tan square x divided by 1 minus tan square x, and this whole thing divided by, again LCM, 1 minus tan square x, 1 minus tan square x, yes, minus 2 tan square x. Yes, tan x into tan x is tan square x. Now this and this will get cancelled. Why? Because when we convert this division into multiplication, we will be taking the reciprocal of this, and when we take the reciprocal of this will go into the numerator. This will be the denominator, so they will get cancelled. Okay, so 2 tan x plus tan x minus tan cube x divided by 1 minus tan square x minus 2 tan square x, which is equal to 2 tan x, no, 3 tan x, tan 2 plus 1, 3 tan x minus tan cube x divided by 1 minus 3 tan square x, which is what we needed. 26th. Okay, now let's look at cos x plus cos y. We have looked at cos x plus y, x minus y. Now what we are going to do is we are going to look at cos x plus cos y. Cos y. Now this is equal to cos x plus y by 2 and cos x minus y by 2. So let's see how this comes. We know cos x plus y is equal to cos x cos y minus sin x sin y. Cos x minus y, let's see. Now this is what cos x cos y minus sin x, no, plus sin y. Now let's add these two, right? Let's add these two. When we add it, what happens? Cos x plus cos y plus cos x minus y is equal to 2 cos x cos y. Sin x sin y gets cancelled, plus minus. That is if we add. Now if we subtract, what happens? Cos x plus y minus cos x minus y. Now we are subtracting it. So when we subtract it, what happens is that cos x cos y becomes negative and this becomes negative. Yes. So this cos x cos y gets cancelled and this becomes minus 2 sin x sin y. Now let's look at x plus y. Let's say x plus y is equal to theta and x minus y is equal to phi. Let's add them. What do we get? Simultaneous linear equations, remember? 2x, y gets cancelled, equal to theta plus phi. So which means x is equal to theta plus phi by 2. Now let's find y. What we can do is x plus y equal to theta, x minus y equal to phi. Now let's subtract it, not add it. So this becomes minus, this becomes plus. So now x gets cancelled. So we end up with 2y equal to theta minus phi. So y is equal to theta minus phi by 2. So which means what? X cos theta plus cos phi is equal to, right? Remember we had 2 cos x cos y. So 2 cos x, x is what? Theta plus phi by 2 cos y. So y is what? Theta minus phi by 2. Similarly, cos theta plus cos, not plus, minus cos phi is equal to 2 minus 2 sin theta plus phi by 2 and sin theta plus phi by 2. Now since theta and phi both belong to real numbers, right? They can be any real number, isn't it? So which means instead of writing theta and phi, we can write directly as x and y. So our identities become cos x plus cos y is equal to 2 cos x plus y by 2 cos x minus y by 2. And similarly, cos x minus cos y becomes minus 2 sin x plus y by 2 sin x minus y by 2. So we actually did two identities in single one, cos x plus cos y and cos x minus cos y. Sin x plus sin y is equal to 2 sin x plus y by 2 and cos x minus y by 2, and sin x minus sin y is equal to 2 cos x plus y by 2 minus y by 2. Let's begin with sin x plus y is equal to what? We know this identity. Sin x cos y plus cos x sin y. Yes. Sin x minus y is equal to sin x cos y minus cos x sin y. Now let's add. So if we add these two, what do we get? We get sin x plus y plus sin x minus y is equal to, now these two will get cancelled. The second terms on the right hand side will get cancelled. So 2 sin x cos y. If we subtract it, sin x plus y minus sin x minus y. Now when we subtract, this will become, the first term of the right hand side will become negative and this will become positive. So which means the first term of the right hand side will get cancelled. So which means we will be left with 2 cos x sin y. They look similar, but remember, here it is sin x, here it is cos x. Once we have done that, let's focus on x plus y. Let's say this is equal to theta. X minus y equal to phi. So this gets cancelled. So x is equal to theta plus phi. So x is equal to theta plus phi by 2. X plus y and x minus y equal to phi. Now we subtract it. So x gets cancelled here. We will end up with 2y equal to theta minus phi. So y is equal to theta minus phi by 2. So our identity becomes sin theta plus sin phi is equal to 2 sin x is what? Theta plus phi by 2 cos y. Y is what? Theta minus phi by 2. Similarly, sin theta minus sin phi, 2 cos theta plus phi by 2 sin theta, theta minus phi by 2. Okay, so again, the previous derivation and this derivation, we have ended up with 1, 2, 1 and 2. Okay, now since theta and phi belong to real numbers, that means we can use x and y in this case. So sine x plus sine y is equal to make it look like a proper identity, that's all. So x plus y by 2 and cos x minus y by 2. Sine x minus sine y is equal to 2 cos x plus y by 2 and sine x minus y by 2. Now here somewhere I had made one small mistake. Let me just correct that. Yes, here. Okay, here in this step, cos theta minus cos phi is equal to minus 2 sin phi, theta plus phi by 2 and sin theta plus, not plus, minus. Okay, theta minus phi by 2. So bye for now. Practice.